So I want to go over negative exponents. They still follow the same exponent laws, so multiplying, dividing, stuff like that, but they work a little bit different, and I want to show you how we get them. So x to the power of negative 3. Before we actually write this, I just want to show a different way to write that. Let's make an actual equation or expression that represents this. So we're going to have x divided by x, and we want these two numbers to subtract to equal negative 3. So I'm going to do 2 and 5. So like we learned in the last video, this is going to be the same as x to the power of 2 minus 5, which is going to become x to the power of negative 3. Okay? That doesn't help though. The whole reason I showed you that was so we can visualize a little better. So let's zoom out a bit. I'm going to rewrite this again. Instead, I'm going to do x squared on top and then x to the 5 on the bottom, 4, 5. Like we talked about when we're dividing, we can cancel these out. When we cancel these out, you're going to notice something. This became 1 over x to the 3. Hopefully you can see the pattern. This became this. When there's a negative exponent, it actually moves past the denominator line, and in this case becomes the denominator. So if I showed you another example, maybe it's going to get a little clearer. If I had a number like y to the power of negative 4, okay, that's going to become 1 over y to the 4. Please be careful. A lot of students get confused when there's negatives and think there's going to be like a negative in the answer or something. It just makes it into a fraction like we can see. Now, there is one more that can get a little trickier when it happens. If I had 1 over y to the negative 3, okay, situation like this, the same thing's going to happen. That negative 3 means that we're going to move it to the other side of the line. So in this case, it's going to become y to the power of 3. So when you have a negative exponent, wherever it is on the denominator or on the top, it means that whatever the base is that's connected to it, it's going to move either up or move down past that fraction line. Let's do another example. This one has the same rule as we talked about before. Okay, I'm going to expand this. This means that this exponent is going to apply to both the x and the y. So it's going to become x to the negative 3 over y to the negative 3. And like we just talked about, this is going to cause it to move to the top. So this is going to become y to the power of 3. This x to the negative 3 is going to move to the bottom and become x to the power of 3. And that's a simplified version. So you can see when you have a fraction with a negative exponent, it actually causes them to invert. Last one's a little tricky. I'm going to deal with this one step at a time. Let's apply this exponent to these two. So it's going to become 2 to the negative 3, x to the negative 3 over y squared. So now we know the rule is that this negative is going to cause the whole thing to move to the bottom. Same with this negative is going to cause it to move to the bottom. You'll notice this is positive already, so it's not going to move to the top. It's just going to stay where it is. So when I move everything, it's going to become 2 to the 3, that moved down, x to the 3, that moved down, and the y squared, that didn't change. You'll notice they're all multiplied together because this was all one term anyway, so when they moved, there was no like addition or subtraction going on between. The last thing is what goes on top. Well, if I was going to put this with brackets, what would the coefficient in front be? It would be an invisible 1 because it's 1 times everything. So we're going to put a 1 there. It would never be 0 because that would mean that there was nothing on top, which is not what there was. So there's a 1. Now, the only thing left to do is we can actually simplify this. So it's going to become 1 over 8 x cubed y squared. I want to show one more example, maybe make it a little clearer. So let's write this with one more step just so we can see it. So we know that x to the negative 3 is the same as 1 over x to the 3. So let's try writing it that way. So I'm going to do 1 over x to the 3 divided by 1 over y to the 3. That is the same as that. Now, I'm going to rewrite this whole thing again. 1 over x to the 3 divided by, that division is the same as that dividing sign right there, divided by 1 to the y to the power of 3. Cool. Okay, so now, hopefully you remember, the rule when we divide by fractions is we invert and multiply. So this is going to stay 1 over x to the 3. I'm going to change my sign to multiply. Let's make it a dot. okay, multiply, and this is going to invert. So it's going to become y to the 3 divided by 1. When we multiply those, it just becomes y cubed over x cubed, which you'll notice is the same as what we said our answer was over here. It's just another way of visualizing it. Now, you can obviously see this is a lot of steps. You don't have to do those steps. We have better things to do. So when you see this, where you have negatives, you can just know, well, that's going to move onto the bottom and become positive. This is going to move to the top and become positive. This is just a way to visualize what's actually happening so you can see it. And that's basically it. The key thing to remember, like we said, when you have a negative exponent, it means it's going to move either to the top or to the bottom of the fraction and become positive instead. Mathematicians don't like writing negatives. A negative exponent is considered improper. So if your answer has a negative exponent, to simplify, you need to turn it into positive. That's it.